Today I will present my project called like a smart automatic street light system using Arduino. And as you see, there are some components. This project combines an LDR, light dependent resistor, or maybe photoresistor, you can say, and a PIR motion sensor. And you can see from there, like, yes, we have the Arduino Uno R3 and a 220 ohm resistor and photoresistor or LDR, you can say, and PIR sensor, 9-volt battery, light bulb, relay CPDD, NPN transistor or maybe BGT, you can say, and 1 kilo ohm resistor and also flyback diode. And our schematic view like that. And after that, we can speak about our project. Yes, as you see, we have the project which is uh, has the main goal of the project is the creating an energy efficient automatic lighting system similar to modern smart street lights used in smart cities. The system only turns on the lamp on during nighttime and only when motion is detected. For example, it's morning and our PIR detect any motion. Lamp is not switch on because it's morning, and when light fade away and get nighttime, and this time if our PIR detector motion detector sensor detect any motion and after that our lamp switch on and how it work. First of all, why I use the resistor with the LDR. The resistor connected to this LDR is extremely important. Without this resistor, like you see, it's 220 ohm. Without this resistor, the voltage values will not be stable or readable correctly. The resistor and the LDR photoresistor together create something called the voltage divider. Like, yes, we learned this subject at class. It's a voltage divider principle. And also the voltage dividers converts resistance changes into measurable voltage values for the Arduino, and this allow the Arduino understand the environment is bright or dark. And I select the resistor value experimentally to achieve more stable sensor readings inside the simulation. Yes, as you see, our LDR terminal 1 is connected to our 5-volt power supply is Arduino, and the other terminal is connected to the A0 like analog pin. And also the terminal 2 is connected to our resistor 1 that is 220 ohm, and it connected to our ground. And also our PIR sensor like have signal, have power and sorry about it, power and the ground. Our ground is connected to Arduino's ground. Our power connected to also the 5-volt power supply, and our signal side is connected to the digital pin Q. And for why it's connected to digital too, like when motion detect, this is give the signal, send signal to our Arduino, and Arduino understand yes there are motion. Yes, and also I use the PIR sensor gives binary output high when motion is detected, low when there is no movement. This helped reduce unnecessary power consumption, and the control lamp safely. I used a relay. Relay is principle of relay. You can see when there are not any signal, any current, this relay will be open like that. But when our signal come into it and get this signal, our relay connect this side and like um, like the complete circuit, and this electric signal come into it and go through there, and our lamp switch on if everything is good, every signal is true, like that. And our also have the flyback diode for this relays have the how can I say this relay have the um, uh, how can I say that another very important protection component is the flyback diode. A relay contains a coil which behaves like an inductor. Yes, we can say inductor. When the relay suddenly turns off, the magnetic field inside of the our relay, our coil, collapse and creates the reverse voltage spikes, and it could be damage our components, our Arduino and etc. For prevent this problem, we used flyback diode, and flyback diode get this voltage on itself and broken. After that, our circuit is not worked properly. We must change it and etc. Find the problem, real problem, and our PIR sensor, and also you can see that I have the NPN transistor. Why I use it? Because if I connect our relay directly to the digital pin 13, it gives the warning. Arduino system, our all digital pins or analog pins have the current recommended current and limited current. For example, for digital pins, there are 20 milliampere is recommended current, and the 40 or maybe 50 milliampere is limit. It means you can best choice for getting current from digital pin is 20 milliampere, and when I connect our relay coil directly to the D13 digital pin, it will give the warning and say that your recommended current for digital pin 13 is 20 milliampere, but you have the 28.6 milliampere, and also I write it in my report. You can see from my academia and SlideShare links and screenshots of them. And for solve this problem, I use NPN transistor. How it worked? It has a collector, base, and emitter. As you see, our emitter connected to our ground, Arduino's ground, and our collector is connected to the relays coil, and also the base of the NPN transistor connected to 1 kilo ohm, 1 kilo ohm resistor, and it connects to digital pin. And with using this NPN resistor, NPN transistor, the transistor works like an electronic switch or amplifier instead of letting Arduino directly power the relay coil. Arduino know only Now Arduino only sends a very small control signal to the transistor base like there, and the transistor then handles the larger current required by the relay. And this protects the Arduino pins from overload and increase the lifetime of pins and Arduino system. And also let we start the simulation and see how it's work. Yes, in there I write the line by line code, like our relay where get this amount from the digital pin 13, our PIR pin like a sensor is 2, it's connected to 2. Yes, you can see signal is connected to digital 2 pin, and for this I write that. And analog 0 is LDR pin. Yeah, you see LDR connected to with blue cable to A0, analog 0 pin. And also that when starting LDR value and PIR value is 0, and we have the night threshold, which is, for example, it's afternoon or it's maybe morning. I don't want to switch on lamp if even they have any motion. I want to, when it's night and also have the motion, the lamp switch on like that. And I use the threshold and void setup pin mode. It's relays output, PIR sensor pin is input, and LDR pin the input, and digital write relay low. It means disconnect this circuit for switch off the lamp. And void loop, yes, our loop is start there, and we read that from analog LDR value like that. Read that, for example, what is the our amount of brightness or light, like that. For example, it's sunny, it's like morning, and if our motion detector uh, detect any motion, yes, you can see it detect, but and also you can see from there PIR is 1. It means it's detect any motion, and our LDR value of LDR is 302, and it's bigger than our threshold, and for this reason our relay is not give the signal to the lamp, and it's not switch on. But if it's a little bit bright and little bit dark, also we have the some motion, but its LDR is 204, and it's not less than our threshold. But when it come through the for example the will be dark, will be night, it will be 132 LDR, and our Arduino understand that from analog pin, read analog 0 pin, and understand that yes, our time is night. Yes, it's night time. It understand that, and ask the PIR sensor. There are any signal which is come through the D2 digital 2. There are any motion? No, there are not any motion, and for this reason, our lamp is not switched on. And when is motion detected like that? Yes, our lamp is switch on because it's night and there are motion. And if motion stop like that, and our PIR understand that there are not motion like the PIR 0, and lamp switch off. And when the outside of the PIR sensor view, the outside of them, any motion is not important because our PIR sensor cannot see it. And that's all. Um, and also the codes like that. If that's lines from 27 to 30 for better visualization like that. In serial monitor we can show the amount of LDR and PIR, and if for example nighttime, like if our LDR value is less than our night threshold, and inside of that again any if like PIR value is high, it means it's 1 or 0. If 1, digital write, it means send a signal to relay high. It means send signal to relay, and when signal come to relay, relay understand that and connect the circuit and complete it, and this coil sent the signal to our lamp like that, and that's all. Thank you for listening, and I appreciate you, and That's all. And this project taught me much more than simply connected components. I learned the relay driving, transistor switching, sensor integration, and circuit protection, voltage divider logic, and embedded system debugging. The coding part was the easier for me because my main field is backend development. However, hardware debugging and correct electronic connections were scientifically more challenging. I used some tools, AI tools, YouTube, Google, technical discussions, and the person who had the experiment about the electronics and uh, try to do my best. Thank you.